Scientific notation is a method of writing numbers by using powers of 10. So it's a way of writing very large numbers or very small numbers in more compact way. So the form of scientific notation is m times 10 to the nth power, where m has to be between 1 and 10. It can be 1, but it cannot be 10. So any number in between. And then n has to be an integer. And remember, an integer is positive or negative whole number. So no fractions, no decimals, or exponents in scientific notation. So in my chart here, I wrote two different numbers in scientific notation and then said which way to move the decimal. So if your exponent is positive when you're written in scientific notation, like this one's a positive 7, you're going to move to the right that many places. So 1.275 times 10 to the 7th becomes 12,750,000. And then for the other one, when you have a negative exponent, so we have 3.5 times 10 to the negative 7th, that means we're going to move left 7 places with our decimal. So you slide it back left 7 places and then fill in those empty spots with zeros. So for a review here, write each number in scientific notation. So the first one is 25,600. So I have to decide where am I going to put that decimal so that I have a number between 1 and 10. So a good spot then would be here. So I would have 2.56. It's always times 10. And then we have to figure out what our exponent is. So we want the decimal to be between 2 and 5, but it's really right here at the end of the number right now. So you have to figure out how many spots. 1, 2, 3, 4 spots. So our exponent is 4. And then if you were given this number and wanted to write it in scientific notation, you want to, again, figure out where can you put that decimal so that you have a number between 1 and 10. So between the 4 and the 8 would be great. So you'd have 4.843, and then always times 10, and then figure out how many spots. 1, 2, 3, 4. That would be 5. This is going to be a negative 5 because this number is less than 1. So it's a smaller number, less than 1. You're going to have a negative exponent. If it's a large number, you're going to have a positive exponent. Then you're given two numbers written in scientific notation, and you are going to have to write those in standard notation. So you're going to start with a 3.64, and then you're going to look at the exponent. It's a positive 5, so that means I'm going to move 5 to the right. So 1, 2, 3, 4, 5, and fill in the empty spots with zeros. So our final answer would be 364,000. Over here, we're going to start with the 6.157, and our exponent's negative 6, so we're going to move 6 to the left. So 1, 2, 3, 4, 5, 6. Fill in those empty spots with zeros. And this is where our decimal is going to be. So remember, there's always another 0 out front of that for the ones place. And there's 5 zeros here. And 6157 for your final standard form, standard notation answer. All right, example 3, simplify each expression, write the answer in scientific notation. So we're going to use those rules that we talked about yesterday to simplify this. So we're dividing two different scientific notation numbers, and we have 10 to exponents. So we have a base of 10 raised to exponents, and we're dividing. So the rule is we're going to subtract those exponents. So we're actually going to have to do negative 3 minus 8. So we're going to have 10 to the negative 11th power when we do the negative 3 minus 8. And then we have to do the 8.1 divided by the 1.3. It's 6.23. And that is in perfect scientific form because that number is between 1 and 10, so we don't have to do any movement of the decimal. And then we add our multiplication symbol. So 8.1 times 10 to the negative 3rd divided by 1.3 times 10 to the 8th is 6.23 times 10 to the negative 11th. And then if we have multiplication with our exponent or with our scientific notation, we're going to do the same thing. We're going to multiply the 3.5 and the 5.2, and we are going to get 18.2. And then it's times 10. And we have 10 to the 8th times 10 to the 5th. So the rule is add those exponents. So that becomes 10 to the 13th. Now we do have a problem here because our number 18.2 is not between 1 and 10. So we actually have to slide this decimal over one more place to the right or to the left. So we have 1.82 times 10. And we moved it one more. We are already at 13 spots slid over. So now we have to move it over 14 spots. So that is your final answer in scientific notation.